This is group 13, and we're looking at unit testing. Craig Fries, Justin, and Michelle. Unit testing is a three-phase system of testing. Firstly, code needs to be written, and then secondly, we split that code up into several chunks. Then we take that isolated code and analyze it using different means, oftentimes looking at the boundary cases and making sure that it's performing its intended function. Software testing is one of the most used forms of testing. Unit testing is, and it's mainstream through Agile and XP development methodologies. And the goal is to try and find the bugs before they become big problems in the project. And so we look at everything in small workable chunks. Involved in unit testing, or who conducts the testing, is the developer and the quality and assurance tester. And the developer will do the unit test before they send it off to the quality assurance tester. Then they'll repeat the test, and then they'll go into more depth until eventually the code can be marked as done.
For the unit testing workflow, there are 4 steps to unit testing. During the create step, a tester determines what they want to test and how they want to test it. Test cases are then validated during the review process, and any errors are addressed. During the baseline step, an expected output is determined for each test case. Lastly, test cases are run, then results are compared with anticipated output. Here's a real-world example of how unit testing might work in coding. As you can see, I've created 2 function examples. A unit test code example has also been created. This code will then test both of these functions to easily identify any errors in the code for the expected outcome.
There are many advantages to incorporating unit testing into your software development lifecycle. Due to the modular nature of unit testing, we can test parts of the project without waiting for others to be completed. This in turn allows for faster production as developers can work on several isolated modules simultaneously, testing along the way, ensuring that their code is functioning as it should, preparatory to doing later integration and system testing. Unit tests help fix bugs early in the development cycle, which translates to saving time and cost. Good unit tests also serve a dual purpose by innately providing detailed project documentation. It helps the developers to understand the testing code base and enables them to make changes quickly. Unit tests also help with code reuse, as developers can migrate both their code and tests to new projects. If done properly, unit testing will result in cost savings in any project and exponentially over time. There are ways to mitigate what some would say are disadvantages when it comes to unit testing. As in life, we must be careful not to take a fundamentalist view of anything we do. Unit testing is one type of tool among many that works well at what it is intended to do when done properly. We must also remember that all things have limitations, and as we remain aware of those, we will reap the benefits of applying any tool with wisdom and order. Unit testing can't be expected to catch every error in every program. It is not possible to evaluate all execution paths, even in the most trivial programs. Unit testing is, by its very nature, focuses on a unit of code. Hence, it can't catch integration errors or broad system level errors. This is why it is recommended unit testing be used in conjunction with other testing activities. Learn more on your own by checking out best practices for applying unit testing to your projects and the many popular industry software tools that are designed to help implement unit testing even more efficiently. Thank you.